The planets don't sit in the solar system in isolation. They're surrounded all the time by radiation. And this radiation comes from two sources. It comes from the sun, and it also comes from outer space, from the galaxy.
Is the particular radiation that's worse than the other?
The radiation from the sun comes continuously. We have this low energy hot gases you've heard about called the solar wind. Okay. And the animation behind me there shows the streaming gases coming from the sun and how they hit the Earth in the Earth system. And also we have from the sun periodically at solar maximum, like we are now, right. We get these energetic bursts of energetic particles. Okay. It's called solar particle events.
Now, how long does the solar wind take to reach the Earth?
Depending on the velocity of it, it takes the order of a day or two. Okay. These very energetic particles, though, can come much faster in a matter of hours.
Now, we're protected by the magnetic field of the Earth from the solar wind?
All of the planets and the other objects in the solar system have two types of protection. They could have either an atmosphere protecting it, or a magnetic field, okay. Or both, or neither, okay. Depending on which planet we're talking about.
Do we have any early warning systems that we can find out if that solar wind is heading our way, or high proton events coming that way?
Well, right now we have a space weather network, and we're observing ejections from the sun. We also have satellites in space that serve as sort of sentinels, telling us when the solar wind and disruptions in the solar wind are approaching the Earth.
Now, what are some of the negative aspects of solar radiation or solar wind as it hits the Earth?
The animation shows how the solar wind gases come to the Earth, and the Earth has a very sturdy magnetic field, a very intense magnetic field compared to many of the other planets. And this magnetic field deflects the solar wind before it reaches the Earth's atmosphere. So the solar wind is forced to flow around the Earth, and it makes this comet-like stretching of the Earth's magnetic field called a magnetotail. Now what happens is the solar wind on the front side doesn't hit the Earth, but it goes around the back, and it causes a disruption in the magnetic field. And this complex interaction with the solar wind magnetic field is what causes the aurora that you see in the polar regions, and it also leads to the radiation belts around the Earth.
And is it true that the auroras are really the only visible way of us showing that there is an interaction between solar wind and the magnetic field of the Earth?
It's certainly the most beautiful and the most dramatic interaction. If you ever have a chance to go up to the polar regions so you can see the aurora, it's really a lifetime event. Very spectacular, very worthwhile.
Now, as we move away from the Earth, we head towards Venus. How is Venus affected by the solar wind?
Venus has a thick atmosphere, very thick atmosphere, but it lacks a magnetic field. So the solar wind just plows into the upper atmosphere of Venus, and it flows around the atmosphere. It tends to strip off some of the atmospheric particles, but it's a very slow erosion of the Venus atmosphere, and it never penetrates to the surface. But now if we take another object, like the nearest one to the Earth, our own moon, right. It lacks both a magnetic field and an atmosphere. And the solar wind just plows into the front of the moon. And this changes some of the electrical properties of the surface because the solar wind carries electrical charge. Right. But it also it might be an important resource, which is very surprising, because what happens is the solar wind hydrogen from the sun hits the moon. It can combine with the oxygen in the soil, form water. That's right. And then this water bounces around, and now we think that some of the water we see in the poles of the moon might be due to solar wind.
Interesting.
Yeah, and right now NASA has a spacecraft called the Lunar Reconnaissance Orbiter.
LRO? Yeah, that's right.
LRO, that's in orbit around the moon. And it is mapping resources, looking for water and hydrogen in the polar regions, and also studying the radiation environment around the moon.